Hello everyone, this is me, Mohin Hassan. Welcome to my 8th ArcGis tutorial. Today we are going to solve some real-life problem in our project 2 using some geoprocessing tools. At first, let us see our today's problems. Here we can see you are given the following special data set with BTN projection for Rajshahi City Corporation. The number 1 is educational facilities and number 2 is ward boundary. Let us open our ArcMap and see our today's data at first. Our ArcMap is opening. Our ArcMap is open. Let us see our today's data set. Go to catalog, and here is our project 2. In this project 2 folder, there is a folder called data. We'll find our data set here. The number 1 is RCC word boundary. Drag it to the ArcMap, and the number 2 data set is educational facilities. Okay. At first, let us explore our data sets. This is RCC boundary, and these are the ward line of the Russia City Corporations, and these are the whole city corporation boundary in the outer surface. And all these dotted shown in the data set are indicating educational facilities. Here you can see this is the educational facilities. Okay. Let us read our first problem. In our first problem, we are asked to prepare RCC boundary using a special data of word boundary. To make a RCC boundary, we have to dissolve this map so that the word boundary between this map are dissolved. For that, we have to go to the geoprocessing from here and click dissolve. And this is our RCC word boundary. We will drag it to the input features. And from here we can change the where we want to save our file. I will let it be default as it is and give it a new name. This is RCC total boundary. And from here dissolve field, this indicates the fields. If we select any of this field, and the dissolve operation will not be applied on that field. We will not select anything. We want to dissolve all the features in the map. So let's click OK, close. And now this is our new RCC boundary. If we turn off this, we can see there is no word boundary in this. The only boundary shown in the map is the outer line of the RCC or Russia City Corporations. Okay, our first test is done. Now, if we see our second problem, in our second problem, we are asked to take a 500-meter buffer as a standard surface area of the primary schools. If you go to the ArcMap and see our data set again, here we can see these are the some dots that indicates the educational facilities or the educational institution. So we are asked that we are given that this individual educational institution serve 500-meter around it. So we have to make a buffer from this every individual educational institutions. For that, we have to go to the geoprocessing here again and click on buffer. And in our input feature, we will give the educational facilities. And we'll set our 500-meter here as our linear unit. And now if we click OK, close, we can see the 500-meter buffer is created here. After creating the 500-meter buffer as our standard service area of primary school, in our next step, we are asked to calculate the percentage of only served area, overserved area, and unserved area within the RCS area. If you carefully notice our problem, then we will see that there are some steps. We are asked to calculate the percentage. We can only calculate the percentage if we at first indicate or identify our served area, overserved area, and underserved area within the RCS area. And again, there is another step. We have to identify the buffer area that are between the RCC area. If we carefully notice our buffer area in the arc map, we'll see there are some areas such as here. We can see there are some areas that are under the buffer area, but this is not included in the RCC boundary. So this we have to delete or erase those area or separate the outer area of the buffer from the RCC total boundary. For that, we have to at first intersect the buffer area with the RCC total boundary. For that, we will go to the geoprocessing here and select our intersect. And in our input feature, then this will be the buffer. We have just created 500-meter buffer from educational institutions, and in our again we want to intersect it from the RCC total boundary. Here we'll drag it here. Okay. Now we click OK. Close. Now, if we see that the colored area, the violet color area indicates these are the buffered area that are included in the RCC total boundary, and in the light orange area, this indicates that these are the areas that are included in buffer but not it in RCC total boundary. So we have successfully detect the areas. Those are served by the educational institution, and those are and included in the RCC total boundary. Now we will go to our next step, and that is to identify the served area, overserved area, and the underserved area. If you carefully notice that in this buffer, for example, in this buffer, the uh, inner part of this buffer area, 500 buffer area, these are the served area. This doesn't overlap with anything. There is a small portion that overlap with the with another buffer area, but this is not as big as others. Here we can see these are some portions that are overlapped with each other for several of times. These are the overserved area. We have to at first make it clear which one is overserved, which one is served, and which is not unserved area. These are this overserved area because this educational area also serve this area. This educational area also serve this area. This educational institution also serve this area, and these are the this is the served area because only one educational institution serve this area. And if you carefully see, these are the areas that are not served by any educational institution, and we can say these are the unserved area. Now if we determine step by step the overserved area, the unserved area, and the underserved area, we will first determine the overserved area. Before determining the overserved area, we must rename the layers to make it clear to us and work more easily and not be confused. Let us see this. This layer indicates, if you turn off this layer indicates the upper portion of the sorry, this layer indicates the inner portion that are included in 500-meter buffer from the educational institution, as well as that are included in RCC total boundary. Okay, so so we will rename this layer with total boundary and included in 500-meter buffer. Let's say we will rename it with buffer plus total boundary, total RCC boundary. Okay. Now this is very clear that this layer indicate the these portions of this data set, that those are included in 500-meter buffer from the educational institution, as well as included in the total RCC boundary. Okay, now we are ready to identify our overserved area. As I said before, these are the overserved area because these are overlapped with multiple buffer area. If we see this area is served by this irrigation institution, this irrigation institution, as well as this irrigation institution. Also, this area is served by this educational institution, this educational institution, and by this educational institution. So these are the overserved area. To identify this overserved area, if we think very simply, you just need to identify the intersect area of this 500 meter buffer area. For that, we will go to the geoprocessing and click on intersect, and in our input feature we will give the total buffer area. Those are included in RCC boundary. Okay, and we will click OK. The intersect operation is operating. Okay. Now if we can see clearly the green area, these are the overserved area. because these are overlapped with multiple buffer area. If we turn off all the layers and only just turn on it, we can see this more clearly. These are the overlap area, or these are the overserved area. So let us rename it. Go to the properties and rename it as overserved area. Overserved area. These are the overserved area. Okay, let us open our all layers again. Now if we think that we can see that this violet colors indicates the served plus overserved area. In this violet colors includes the served and overserved area. If we Okay, now if we unmark this layer, the overserved area, again our area will be as before. Again, if we think, we can clearly understand that these area, this violet area, that these are included in RCC boundary. These are included in 500-meter buffer from the educational institutions, and this indicates the served area as well as the overserved area, because these are the served area and these are the overserved area. These all are included in this buffer plus total RCC boundary. If we turn off and turn on this layer, we can clearly understand this. And now if we erase the overserved area from this total served and overserved area, we will find only the served area. Okay, and this is our overserved area. If we erase these areas from the served and overserved area, total served and overserved area, we will find only the served area. Okay, for that we will go to the geoprocessing again and click on the erase tool. There's an erase tool, or we have to search for it. Search for erase. Yeah. Okay, this is our erase tool. Let open our erase tool. Okay, now in our input feature, we will input the area that include over served area plus the served area. These are included in this layer, that is buffer plus total RCC boundary and served and overserved area. We can rename it later. I will rename it later to make it more clear. Okay. In our input feature, we have just drag down this layer, and then in our erase feature, we want to erase the overserved area so that we can find this only served area. For that, we'll click there this and drag down this here. Okay. Now we'll rename it with served area, only served area. Served area, and click OK. Make it close. Okay, to make it more clear, we'll change the color from here. We'll make it yellow. Let's make it yellow. Now this is very clear that these are the area, those are only served, and the green, light green area, these are the area that are overserved. After identifying the served and overserved area, now if we dissolve this served and overserved area and erase this from the total RCC boundary, we will find the unserved area. Now we will dissolve this served and overserved area. For that, we will go to the geoprocessing, go to dissolve, and select this served, overserved, and this total area, and dissolving, and this is the total served and overserved area. Overserved area. Okay, now if we erase this total served and overserved area from the total RCC boundary, then we will find the unserved area. For that, we will go to the geoprocessing area and search for a tool that is called erase. Yes. Okay, in our input feature, this will be the total RCC boundary, RCC total boundary here. And in our erase feature, this will be the total served and overserved area dissolve. Okay, now if you click OK, we will change the color of this area and give it orange. Now we can see clearly these are the unserved area. So we'll rename it. Click OK. Okay. Now we get all three our component, that is served. That is served. This is the served area. If we unmark all, and this is our first served area. These are the served area. Then these are the overserved area, and lastly these are the unserved area. Okay. Now we have to dissolve all these three areas individually, and then we have to merge them all to make them a total to input them in a one shape file. We'll merge them one by one. Processing. Sorry, we'll dissolve them one by one. Unserved area dissolve. And now we'll go to the served area dissolve. For that we'll go to the dissolve. And served area dissolve. Okay. Then we'll go to the overserved area dissolve. For geoprocessing dissolve overserved area, and do overserved area dissolve. Okay. Close. And now finally we will merge all of these three dissolve shapefile to to have them in a one shapefile. We select overserved area dissolve, served area dissolved, and unserved area dissolved, and click OK. We'll name it all dissolve. We'll name it all dissolve. And now if we go to the attribute table, we'll find here. Here is the this is our total over sub area. This is our total over sub area, and this is our served area, and lastly this is our unserved area. Okay, let's give them a name. For that we will add a field from here. This is it's a category, and it will be a text. Now we will want to edit it. For that we will go to editor, start editing, and this is our all dissolve. Okay. Now we can edit it. And the first one is, if you mark it, you will see this is the overserved area. Then the second one is total served area. And this is finally last one is the unserved area. Okay, we save on edit from here. So it's just a minute. Okay. Now if we see our questions, there we have asked to calculate the percentage of total served area, overserved area, and unserved area. To calculate the percentage, we'll right click on the shape area and go to the statistics and copy here, copy the sum of this total area, that is here. Okay. Now we'll go to here and open a add new field. This will be our percentage, and it will be float. Click OK. Now we want to edit it. Our editor is no. Now we want to determine the percentage. For that we will go to the for that we will mark it and right click on it and go to the field calculator. Okay. And now we'll write the formula of the percentage. And for that we want the percentage of shape area, and for that we'll give a first bracket, then select shape area, then into okay, shape area divided by the sum of the area that we have just copied, close our first bracket, and then we'll into 100. Click OK. We will get the percentage of this uh, area of served area, over served area, and unserved area. In our next question, we have asked to calculate the percentage of served area, over served area, and unserved area within the RCC area against each word with reference to total RCC area. To perform this, we will have to identify the served, over served, and unserved area with the word number of this RCC boundary. For that, we have to go to the geoprocessing and search for a tool that is identity. This is our identity. And now in our input feature, the it will be in our input. There will be the RCC word boundary, and in our identity feature there will be the all dissolve, and this will be our all dissolve identity. Okay, now we'll go to the attribute table of this all dissolve identity, and from here we will select all and copy them, copy the selection, and go to our Excel, open a new blank workbook and paste it here, and go to insert and insert a pivot table, new worksheet. Okay, now from here in our rows there will be our RCC word number, that is our 1 2 3 4, that is our word number, and then in our columns there will be categories, that is our served, over served, and unserved area, and in our values there will be shape area. Now we go to the value field settings, show values, and remove numerical data and percent of row total. Now we can see that in number one word there are no unserved area. That's why this is 00. There are 89.49% workshop area and 10.51% served area, and the grand total is 100%. So our second question is done. That is calculate the percentage of served area, workshop area, and unserved area within the RCC area against each word which refers to total RCC area. In our next question, we are asked to calculate the percentage of saved served area, or served area, and unserved area within the RCS area against each word which refers to word area. We have done it before, and now we will calculate the percentage of served area, over served area, and unserved area within the RCC area against each word which refers to RCC total area. For that, we will go to the arc map again, and from here, and this is our shape area. We will right click on it and go to the statistics and copy the sum of the total area. Copy the sum of the total area, and then go to the go here and add field. This is our next percentage according to RCC total boundary. It will be a float. Click OK. Then we will mark it. Right click on it and go to the field calculator. And our formula will be shape area divided by the copy total area, close our bracket, into 100 and click OK. Now this is our total percentage of every served, unserved, and overserved area according to the RCC total boundary. This is the answer of our question number 2, and previously we have done our question number 3. Now in our question number 4, we have asked to calculate the percentage of population for unserved area, overserved area, and unserved, overserved, and served area of within the RCC area. Okay, to solve our next problem, we have to calculate the percentage of population for unserved area, overserved area, and underserved area within the RCC area. To calculate the population, we have to identify the population of 2012. For that, we have to add a new field over here and add a field that is population 2022 equal to float. It could be float or shortened integer. Now we go to the field calculator. To calculate the population, we have to use the formula. The formula will be this. The formula will be the population of 2012 will be equal to population of the previous year, that is here in 1991, and into e to the power RT. Here E has a value that is 2.71828, and R is the growth rate that is given in our shapefile in our activity table, and T is the time from 2000 from 1991 to 2012, that is 2022, that is 32 years. Okay, now if we write our formula here, that is population of 1991 into plus e to the power in the value of e is 2.7181 to the power first bracket. Our growth rate will be this our growth rate into the time gap, that is 32 years old. Close our bracket. We click OK. This is our population of 2012, 2022. Okay, after calculating the population of 2022, now we have to calculate the density of the population. To calculate the density, we need the population of 2022 here, and let's freeze this field. And we need the what area in square kilometer, that is here we have identified it earlier. Now we will add a new field from here, add new field, and this will be density of a world population, and the data will be float. Now we right click on it and field calculator, and from here we will go to the to select population of 2022 divided by the area square kilometer, area in square kilometer there, and click OK. Now we get the density of what populations here. Okay, now we have density of what population and the shape area of in a square kilometer. Now we need to identify the population by category, that is served, overserved, and unserved. For that we will have to add a new field, name it as population by category, and the type will be long teaser. Click OK. Now we'll right click on it and go to field calculator, and the formula will be density watt population into shape area at square kilometer, and we'll click OK. This is the population by category. You can see. Okay, let's freeze this field also. Now let's see our question again. Uh, the question says calculate the percentage of population for underserved, overserved, and unserved area within RCC area. For that, we have to select all from here and copy them and go to our Excel file, paste them here, then go to insert and insert a pivot table. Okay. Now in rows there will be our category. This is our category. This is the category. And in values, there will be the population by category. Let's find it. Population by category. This is our population by category. Now we go to the value field settings. Set it as. This is our answer of our question on D. This is the answer of our question on D. It says calculate the percentage of population for underserved area, overserved area, and unserved area within the RCC area. Okay, we'll copy it now and paste it in a Word file. This is our question on D. Sum of the population by category. Now in our question on E, we are asked to calculate the percentage of population for unserved area, overserved area, and served area against each ward which refers to total RCC area. For this, we have to calculate the percentage of population for ward in total RCC area. Okay, for that we'll go to the arc map again. Okay, now we'll add another field. This will be the percentage by ward. Click and the layout would be float. Okay. Now to calculate the percentage by word, we need the total population, that is here, population by category. Right click on it, go to statistics, and the sum, copy the sum. Okay. Now we'll right click on it, go to our field calculator, and from here we will select population by category. Here is the population by category into population category divided by total population that we have just copied. Your bracket properly, and lastly into 100. Click OK. So this is the percentage with respect to the total category served, unserved, and overserved with respect to the total RCC boundary. Let's freeze this also. Okay. Now again we will select all, copy the selected, go to our Excel file, open a new sheet, paste them here and insert a pivot table. Now in pivot table, here will be the RCC word in the rows, and in columns there will be category, and in values there will be the percentage of ward population. Okay, this is the answer of our question on E. Now let's copy this and paste it in our answer sheet. Okay, now in our question on F, we have to do the same work, but this time with the reference to ward area. So let's go to our arc map. To calculate this, we need the percentage in ward population, percentage of ward population, that is here. We have to add a new field, name it as percentage with ward respect to ward area, and it will be float. Click OK. Okay, now right click on it and go to the field calculator, and the formula will be population for category, that is here, population by category divided by population of 2012, close it by bracket, and lastly into 100. Okay, so this is the population of percentage of respect on respect to ward area. Now again select all, copy the selected, go to our Excel file, open a new sheet, paste it here, and insert a pivot table. Okay, in our total, now here will be the in rows there will be the RCC word, in columns there will be category. Let's find our category. There is the category, and in values there will be the percentage respect to word area. Okay, now we'll copy this table and paste it in our answer sheet. This is the question number F, and this is our answer. So we have just calculated the percentage of population, calculate the percentage of population for unserved, overserved, and underserved area against each ward which refers to ward area. That's all for today. Thank you everyone for your patience.